Guys, I'm Prashant
And I'm Chitij.
and this is Sagar Katiria, and we're gonna present one short tutorial on Nx Cam on the models we made using SolidWorks. So let us begin.
So first of all, you import the file.
So these are some of the recent files that we made using SolidWorks. There's a chest piece, there's a gearbox casing, there's a gear, and there's a hub. So we'll be making this tutorial on the gear casing that we made. You can use the file option to open the file. This was available in the recent, so we directly opened it. So here's the file, and this is the menu that you get after opening it. So what you see right now is the file that is open after, like it is the file where you can make the cam changes. But like if you want to open any recent file of yours, so the process for that is you click on open, you click on the file, the CAD model that you want to
Either
open.
maybe SRD PRT file or PRT file.
Yeah, it can be any sort of files that SolidWorks saves as.
SolidWorks saves. Yeah.
And you need to click on file, then new. After, like if you open a SLDPRT file, and then you have to click on manufacturing, general option will be here, and then click on OK, and the window that you will get is the same window which you get right now. And
you can also measure the various dimensions involved in this through the menu option, and then you go to the analysis where you can measure the various distances, the diameter of the hole, the length of the overall component, and various other dimensions, and then you can check it, and according to that you can decide the tool which you want, what should be the size of the tool used, and this is how you measure the dimensions.
and the window that you see right now is the operation navigator tab, and this is the operation navigator machine tool. When you plus click on the career option, you'll get to see all types of tools that you have used. And this is the navigator geometry. This is a very important part of the geometry because this
shows the various operations involved in the manufacturing this component.
Yeah, so like this is very important because if you don't fix the geometry correct, it won't proceed any further. So you have to make sure that the axis that is being shown right now, ZM, XM and YM, is the same as the tool axis that you'll be using later on. If you want to change it, double click on workpiece, and you can change the settings. Like you can specify the part here, and you can change the tool axis at this point of time. So later on there won't be any error. This will include all the processes that is being happening in your model. The step hole, which is including all the holes, the step 1, like these are for holes, this is for the planar part, and so on. So like these are the three main tabs that you will be using. As soon as you open the file, the first thing you need to do is create a tool for yourself, and it will be according to the model that you want to manufacture. So when you click on create tool, you will get various options. The type will be mill planar, mill contour, and so on. So we are going to do milling, so we'll choose mill planar as the option. If you click OK, you'll get to choose the different size and the length and the turns you need in your tool. The tool diameter, the radius, angle, length, and the flute length, and the number of flute. So that is the specification of what type of tool you want to use. If there are short holes, you need to reduce the diameter, and likewise. And you can name your tool with the name you want to use, and when you click on OK, your tool will be created. And you can check the tool in the career option. The tool will be here in the bottommost part. When you create the geometry, it'll in this you are you can create you can define the geometry in which the working will be done. The operation is the most important part. Like after you're done with creating the tool, you can directly create operation for your file. And as you click, like these are the different type of operation that can be performed. We're going to do floor and wall milling, plane milling, floor and wall with IPW. So there are different type of operations. So when you click on OK, you will get to choose the part on which you have to specify like perform this operation on. So when you click on specify part, you can click on the object that you want to work on, and when you and after like selecting the whole body, you have to select the specify cut area floor, in which you select all the holes, and especially like if you want this side to be chosen as the cutting side, you can choose this side. You can select as face, a group, a sheet body, or the whole body as a whole. So right now we're going to work with face, so we're going to select face here, and we're going to click on the part that we need to perform the milling on. So after selecting this side, when you click OK, like these the operation that will be performed using the tool that you have selected will be performed for these sides. And when you click OK, the operation will be created, and that operation can be checked in the operation navigator geometry, that it will be created right here as the step hole, and these things are created. So for example, when we were going for surface planar, we chose a tool for ourselves and we went on create operation, and in the part body we selected the whole body, and in the cut area we selected the part that you can see right now. And after we are done, we generate the tool path. This will generate the path that the tool will follow while making the entire gear casing. And you're just gonna click OK and OK because it takes a break after each path change. So we're gonna just click on OK again and again until and unless all the things are completed. So this will generate the tool path for you, and when you verify the tool path, you can see the path that it will be following. And 3D dynamics, when you go down, you can change the animation speed and you can play it and check what path will the tool follow and how will the whole process take place. So you can just fast forward it and it will show you how it will work and how it will make the entire gear casing. So as you can see, the tool is working and the specified path at the exact way that we wanted it to work. And we'll just fast forward a little bit more. So different operations are being performed by the tool path. It includes milling as well as drilling, and the milling is taking place into for 2 or 3 times in the same area, just because for the surface to be more smooth and for a better surface finish. So it's almost completed now. And as it gets finished, you can see that the whole gear casing is ready, and there are different colors which indicates the different quality of surface finish that the gearbox has, gear casing has right now. The post process will give you the G code. Like if you want to work for a milling 3 axis, you can just click on the post process. You can select mill 3 axis here, and if you click on OK, you'll get the G codes that you can put in a machine, and that will follow the same tool path that you have specified right now, and it will make the entire gear casing with a block of material that you want to use. So here we can see that we have the entire G code ready. It will starting from N0010, it's ending till all the way to 9720. And if you want to document it, if you want to make a final report of this, you can click on shop documentation. You can click on HTML Excel link. It will open in Chrome, and it will include all the processes that you have done, and screenshot and the pictures of the final gear casing along with all the processes that you have done. So it will contain the operation that you are performing, the type, the practice mode, and the time that it is being taken. So we are doing 15 processes in the file, and that is concluding the entire process.
Thank you.
Thank you so much.